Welcome to a brand new episode of Green Dolphin Science. Today, we're diving deep into something really fundamental, the link between, well, our cities and the food we eat.
Yeah, it's a critical connection. And the sources you shared focus on this specific study from Pernambuco, Brazil.
That's right. Researchers there were looking at heavy metals landing on lettuce crops, mainly from traffic pollution.
We've got the actual paper published in Food Chemistry, some images too showing the study area. It's near a pretty busy highway intersection in Recife, BR 101 and BR 232.
Ah, okay. And there are graphs showing the metal levels in the soil too.
Exactly. Copper, lead, cadmium, nickel, and zinc concentrations.
Okay, so the big question we're trying to tackle here, I guess, is with cities growing and traffic getting worse, should we be worried about the safety of vegetables grown nearby?
That's the core of it. Our mission today is really to unpack this study, figure out the key takeaways, and see what it actually means for you without getting too bogged down in the heavy science.
Right. Let's make it clear and relevant. So maybe start with the basic problem. Why do they even do this study? What's the concern?
Well, it starts with urban air pollution. Cities have emissions from industry, sure, but vehicle traffic is a huge source.
And those emissions aren't just smoke, they contain heavy metals.
Precisely. Things like lead, zinc, copper, these metals get into the air, attach to particles, and then they settle on buildings, on roads, and importantly, on soil and plants.
Which is how they could potentially get into our food.
That's the pathway, yeah. If crops absorb these metals, we might end up ingesting them.
Okay, so why lettuce specifically? Why not carrots or tomatoes?
Good question. Lettuce, Lactuca sativa, is kind of a perfect canary in the coal mine for this.
How so?
Well, several reasons. First, it's grown a lot in those green belts right around cities, so it's close to the pollution sources.
Okay, proximity matters.
Definitely. Second, we eat a lot of it, and often raw. No cooking process to potentially alter or reduce the contaminants.
The raw factor. Makes sense.
And third, you can grow it pretty much year-round. That means it gives researchers a continuous way to monitor potential contamination levels throughout the year.
Got it. So a good indicator plant. Let's dig into the study details then. Where exactly was this conducted? You mentioned Recife.
Yes, near that major highway junction, BR 101 and BR 232 in Recife, Pernambuco. Think lots of cars, trucks, constant traffic.
So like ground zero for traffic pollution.
Pretty much. And they collected samples, two types of lettuce, crispa and capitata, and soil samples too, from two different spots near the intersection, sites A and B.
Were they just looking at the topsoil? Or did they go deeper?
They looked deeper. They sampled the top layer, 0 to 20 centimeters, and then the layer beneath that, 20 to 40 centimeters.
Just trying to see how far down the metals might have gone.
Exactly. And they analyzed both the soil and the lettuce for those 5 metals we mentioned: copper, lead, cadmium, nickel, and zinc.
Okay, so they measured the total amount, but how did they know what the plants could actually use or absorb?
That brings us to a really key idea: bioavailability.
Bioavailability. Explain that a bit.
Okay, think of it like this. Imagine the soil has a bunch of metal, but it's locked away in forms the plant roots can't access. Bioavailability is basically the amount that's unlocked and available for the plant to take up.
So just because a metal is in the soil doesn't mean the plant will absorb it.
Right. It needs to be in a chemically available form. So the researchers measured that available portion too. It's crucial.
That makes a huge difference. Okay, so what did they find in the soil then? What were the big results there?
Well, the most striking finding, honestly, was the lead, PTP. They found really high concentrations in that top layer of soil, 0 to 20 centimeters at both sites.
High compared to what?
High compared to Brazilian safety standards, the CANAMA resolution 422,009 prevention value. One sample clocked in at 140 milligrams per kilogram. That's quite high.
Wow, 140 milligram kilogram. Yeah, that sounds concerning. Was this expected?
Here's where it gets really interesting. They compared their findings to a study done in the same area back in 2006.
Yeah.
The lead levels had increased by about 1,000%.
1,000%. That's staggering in roughly 15 years or so.
Exactly. It's a massive jump. And it really highlights how quickly these things can accumulate,
Absolutely alarming. What could possibly cause such a huge increase? Leaded gasoline is banned, right?
It's been banned in Brazil since 1993, yes. But the researchers think it could be a combination of things. Increased traffic volume over the years is one likely factor.
More cars, more residual pollution, even from unleaded fuel components or wear and tear?
Possibly. And also improper disposal of things like old car batteries or other parts that still contain lead. Lead is persistent. It sticks around in the environment for a very long time.
So legacy pollution plus maybe ongoing sources.
And they also pointed to another study suggesting the irrigation water used in that area might also have high lead levels. So it's potentially coming from multiple directions.
Okay, a complex picture for lead. What about the other metals? Copper, cadmium, nickel, zinc?
For those, the concentrations in the soil were generally below the Brazilian safety standards, so less immediately alarming than the lead.
But were there differences between the sites?
Yes. Site B tended to have higher concentrations of all the metals in the topsoil compared to Site A.
Which probably relates to traffic patterns, maybe closer to the heavier flow.
That's the likely explanation, yes. More deposition of those airborne particles carrying the metals at Site B.
Okay, now back to bioavailability. You said it's key. For all these metals in the soil, how much was actually available for the lettuce to potentially absorb?
Generally, only a small fraction of the total amount was bioavailable, and mostly in that topsoil layer, the 120-centimeter zone.
Any metals stand out as being more available than others?
Copper and zinc show the highest relative bioavailability. Cadmium, interestingly, had basically zero bioavailable concentration.
And lead. With those super high total levels, was much of it available?
Actually, no. The bioavailability of lead was low.
So lots of lead there, but kind of locked up from the plant's perspective.
To a large extent, yes. But because lead is so toxic, even at low levels of exposure, and because the total amount was so high, the researchers still flagged it as a major concern for the soil's health.
Right. Even if it wasn't getting into this crop easily, having that much lead sitting there is not good long term.
Okay, let's switch to the lettuce itself then. What did the analysis of the actual vegetables show?
This is where it gets a bit surprising, given the soil lead levels. For the most part, the concentrations of the heavy metals in the lettuce samples were below the maximum levels allowed by Brazilian regulations at that time.
So the lettuce was considered safe to eat based on those standards, despite the soil?
Generally, yes, according to the limits they were using from Decree 558711965.
Huh. But was everything perfectly fine? Any exceptions?
Well, there was one notable thing with zinc, Zine. Zinc levels were consistently higher in the lettuce from both sites and in both varieties.
Higher than the other metals?
Yes. And in one case, the capital lettuce variety from Site A, the zinc level actually went over the regulatory limit.
Okay, that sounds like a potential problem then. It could seem that way, but the researchers offered some important context. Zinc is actually an essential nutrient for lettuce. Plants need it to grow.
Ah, so the plant might just be good at taking up zinc because it needs it.
Exactly. They suggested it might reflect a high natural transfer rate for zinc in lettuce, rather than necessarily being harmful contamination from the traffic pollution itself.
That's a really important distinction. Okay, critical question. What about the lead in the lettuce? Did those high soil levels show up in the leaves?
No, they didn't, and this was a really key finding. The high lead in the soil did not translate into high lead in the lettuce.
So the transfer from soil to plant was low for lead.
Very low, it seems, in this specific situation, this soil type, these lettuce varieties.
That's definitely somewhat reassuring, at least for people eating that lettuce. You mentioned transfer factors before. Can you break that down?
Sure. The transfer factor, or TF, it's basically a ratio. It measures how efficiently a metal moves from the soil into the plant.
How do they calculate it?
They divide the concentration of the metal found in the plant tissue by the concentration of that same metal in the soil it grew in.
So a high TF means the plant readily sucks that metal up.
Exactly. It's like the plant has a strong preference or ability to absorb that specific metal from that specific soil.
And what did the TFs reveal in this study? Did the lettuce varieties differ?
They did. They found that the Capita variety, the head lettuce type, was better at accumulating zinc compared to the Crispa variety, the leafy type, even when grown in the same spot.
Interesting. Same soil, different uptake by different varieties.
Yep. And they also compared the same variety, Crispa, grown at the two different sites, Site A and Site B.
Yeah.
For most metals, the uptake was similar. But for nickel, the Crispa lettuce at Site B had a higher transfer factor.
And why was that?
They linked it back to bioavailability. The soil at Site B likely had nickel in a more bioavailable form, making it easier for the lettuce to absorb.
Wow. Okay. So it's not just the total amount or the plant variety, but also the specific chemical form of the metal in that particular soil. It's complex.
It really is. It shows you can't make simple assumptions.
So let's try to wrap this up. What's the main conclusion, the big picture takeaway from this specific piece of research?
The headline conclusion was that the lettuce grown near this busy highway intersection in Reci at the time they did the study, was generally not contaminated with these traffic-related heavy metals above the levels set by Brazilian regulations.
Okay, so immediate reassurance for consumers of that lettuce then.
To some extent, yes. But, and this is a really big but, the study strongly emphasized the concern about the high lead levels in the soil.
The soil itself is the warning sign.
Absolutely. Those levels are a serious red flag for potential future contamination. It could mean that, over time, the area might become unsuitable for growing food crops if that lead keeps building up or becomes more available.
Especially with that 1,000% increase they saw over the previous decade or so, that trend is worrying.
Extremely worrying. It suggests the problem is actively getting worse, potentially quite rapidly. So while the lettuce might test okay now, the foundation of the soil is showing signs of significant stress.
And the study also showed that different lettuce types handle metals differently.
Right, which adds another layer of complexity to assessing risk. You can't just test one variety and assume it applies to everything grown there.
Okay, so stepping back, what does this deep dive tell us, especially for you listening? This Pernambuco study gives a really fascinating snapshot, doesn't it? It shows this complex dance between city pollution, the soil, and our food.
It really does. And it's striking that even with high soil contamination, like with lead here, it doesn't automatically mean the vegetables are unsafe right now.
Yeah.
Bioavailability and how the specific plant takes up elements play huge roles.
But here's where it gets, I think, really thought-provoking. The study makes it clear that the soil contamination, that legacy laid, possibly from decades of traffic, maybe combined with waste issues, is a serious long-term threat.
Yeah, it raises a critical question for all of us, really, thinking about urban and near-urban agriculture everywhere. What are the cumulative long-term effects of pollution on these soils?
And consequently, how do we make sure our food supply stays safe as cities expand and traffic potentially increases?
Exactly. This study might show okay lettuce today, but the soil's health is clearly compromised, which could impact future crops or maybe other types of vegetables grown there absorb metals differently.
It really underscores the need for continuous monitoring, doesn't it? And for more research looking at different crops, different soil types, different cities.
Absolutely. We need a much broader understanding. This study is one piece of a much larger puzzle about ensuring food safety in an increasingly urbanized world.
It's a reminder that being informed is an ongoing process. There's always more to learn, more to unpack. Thanks for joining us on this deep dive today.